Okay, we are continuing on in our strategies for factoring a quadratic trinomial where a is not equal to 1. So we're going to use in this video what is called area method or box method. You can call it either, and I might call it either. Okay, so here's the idea behind the area or box method. All right, it's going to be very similar to factor by grouping. It's just more of a visual way. So this might be helpful for you if you are a visual learner or you like to see things organized in a visual component. All right, so I'm going to start by doing A times C, just like we did in factor by grouping. All right, so if I do A times C, that's 3 times 15. So that's going to give me 45. And keep in mind this is a negative 45, so just be aware of that. Okay, and then we're going to do our factors just like we've been doing. And again, we want these to subtract to give me 4. So obviously 45 minus 1 is not going to be it. 15 minus 3 is not. 4 does not go into it, so 5 and 9. There we go. So 9 minus 5 is going to give me 4. Okay, so I know this is going to be it. And it's a negative 4, so I want the 9 to be negative, the 5 to be positive. So instead of breaking up that middle term into two different terms, we're going to draw a box. And you're going to split that box or that square into 4 different little boxes. In opposite corners, I want you to put your first term and your last term. Okay, so we're going to have 3x squared in one corner and negative 15 in the other corner. Make sure you take your sign with you. All right, and the other two corners is where we're going to use our factors. So we're not using this in the box. We're using these two. So it is kind of like we're splitting the middle term. We're just not going to write it the way we did in factor by grouping. Okay, it doesn't matter where you put which one. So the 5x, remember these should be x's because this was negative 4x. So I would have positive 5x and negative 9x. Okay, so this is representing area. Okay, so I'll get to the area. What we're going to be doing is if we add all these together, that would be the area of this rectangle. And what we're going to try to do is find the dimensions of that rectangle. Okay, so it's not always going to be a square, obviously. It could be a rectangle or something like that. So here's what we're going to do. In each row, so I've got a row here and a row here, and I've got a column here and a column here. Okay, so in each row and in each column, I'm going to do the greatest common factor. So you see how this is very similar to factor by grouping, where we have different groups and we're going to do the greatest common factor. So in this row, I have 3x squared and 5x. So there's no coefficient in common, but just x. In this row down here, I do have negatives. So remember, if I have a negative in that first one, always factor out the negative. So that would be a negative 3. In this column, so now I'm doing this first column. All right, so I've got 3x squared and negative 9x. So that would be a 3x. And then in this second column, I've got a 5x and a minus 15. So that would be a 5. Okay, so all we're doing is we're saying this over here is going to be one parenthesis. These numbers down here are going to be the other parenthesis. Now here's why that works. Think about if I have just this 3x squared box, okay? What we've done is we've broken down the dimension of that rectangle to be this one is x and then this one is 3x, okay? Over here, this negative 15, I'm just going to use the green one. What we've done is we've broken this down into this dimension of this side right here is negative 3, and the dimension of this side of that rectangle is 5. So negative 3 times 5 gives me a a rectangle of negative 15. And then the same thing with the other ones. We've broken this one down to be a negative, we've already determined that measure is negative 3, and then this measure is 3x. So you see how negative 3 times 3x is negative 9x. So if we break these down into all the individual rectangles, you can see how they all make sense. Now if I add them, so if I take this whole side, so I do that whole side is x plus a negative 3, or x minus 3. And then this whole side of this big rectangle is 3x plus 5. All right, so that's where we're getting the dimensions of that entire rectangle. So we are saying x minus 3 times 3x plus 5 would give us the 3x squared plus 5x minus 9x minus 15. And you can check it and it would come out the same. Okay, so that's the area method. So we're doing dimensions of rectangles in order to help us visually see how those components are broken down into its factors. Okay, let's do another one. Actually, let's write down the steps and then we'll do another one. So area method summary. This is a very important note. Factor out the common monomials first. So when we do the GCF, it's very important to do that. So if your trinomial can all be, if every single term can be divided by 2, you need to do that. Here's why. If I have a square like this, and let's say it's a 3 by 7, and then I multiply the dimensions by 2, all right, then that's going to give me 6 by 14. All right, so I'm going to get a completely different square, but I want to reduce that because it's going to give me a similar box. So if I try to work with this one, then I'm going to be having a lot of extra numbers and it won't turn out nicely. So we don't want this one. We want this one, and then we're going to put a 2 in front of it and say, oh, we multiplied all our dimensions by 2. Okay, so that's just an example. All right. So always, if you're factoring with the box method or the area method, always look for your greatest common factor first. In fact, you should always do that, but it's especially important with the box method because otherwise it won't really work. Okay, so remember we said we find A times C, and then we find all of the factors of AC that add up to be that B term. We fill in the box. Remember that we have opposite corners, right? So this would be your AX squared, this would be your C, and then these would be your M and your N, right? Okay, so make sure you're filling in the box appropriately too. All right, and then find your common factors in each row and column. So that's your GCF, and then write the factors, and you can check if you want to. All right, so if you need more time to write that down, pause the video. I'm moving on. We're going to do another one using the box method. So we're doing A times C, which is going to give me 28. Well, that's a nice number. Not so crazy. And then this last one is going to be what adds up to be 11. So I'm going to draw the box. So in opposite corners, my AX squared and my C. And the other corners are my M and my N, like I'm calling these my M and my N, or the two numbers that add up to be your B. So that's 4x and 7x. Again, I could have put them in the other way around, it doesn't matter. As long as they're in opposite corners, that's okay. All right, so doing the greatest common factors in each row in common. So this first row, top row, that's going to be 2x. Second row is going to be 7. And this first column, that's going to be just plain old x. And the second column, that looks like it's just going to be 2. So my factors would be 2x plus 7, and then x plus 2. Let's do a quick check. You could do this mentally or write it out. So 2x squared plus 4x plus 7x plus 14. So is that going to give us what we started with? Yes. Okay, so we're good. All right. Try this one on your own. So pause the video, try it on your own, use the box method, and see if it works out for you. Okay, down at the bottom here, I have the answer x minus 2 and 8x plus 3. Make sure that when you did this second row right here, see how this first one was negative, so that's how you know to do a -2 there. So just be careful with that. Also, I want to make sure that we're hitting the original purpose of this. If this was equal to 0 and it factored to equal this, we would again be setting these equal to 0. So you can see how all of these are just ways to help us solve quadratic equations. And there are other reasons why we want to factor as well, and you'll get into those more in Algebra 2. For our purposes, it's going to be for solving in geometry.